So we're going to dive a little bit deeper into this stoichiometry and look at a couple of concepts that really are much more applicable to what we do in lab and to general and to reactions in general. Um, but when we talk about this concept of theoretical yield, what we're looking at is how much product could I make if I take the right molar ratios based off of the balanced equation. um, how much product could I make? So theoretical yield is something that we calculate, um, and it's the amount of product you could theoretically make. And quite often in our chemical reactions, one of our reactants is something known as the limiting reagent, meaning it's the only, or it's the reactant that will determine what that theoretical yield looks like. So the limiting reagent, as the name implies, limits the theoretical yield. Now, to kind of put both of these into perspective, I'm going to go back to the very first practical cooking example at the beginning of this unit. And again, let's talk about pancakes. In this example, I had said that if you take 1 cup of pancake mix and a 3/4 cup of milk and 1 egg, we could make 8 pancakes. And also in this, we were looking at, well, what if I wanted to make more than that? So I want to make 24 pancakes. And we had said that that would require 3 eggs. But what if I only have 2 eggs? So what does that mean in terms of the number of pancakes I could make? Now, some of you out there that cook or that bake just say, "Oh, grab some applesauce. That will work in place of an egg." And that might work in the kitchen, but in the lab, we can't really just randomly grab another reactant without changing the whole reaction. So what happens if one of my reagents is doesn't fit the ratios that I need to have? Because I could have an infinite supply of pancake mix, of milk, but with only 2 eggs, how many pancakes can I make? I mean, let's set up conversion, a unit conversion problem here. If I have 2 eggs and I know the ratio is 1 egg makes 8 pancakes, I can make only 16 pancakes. And this is what we would call our theoretical yield. That if I had an infinite amount of the pancake mix and an infinite amount of the milk, but only 2 eggs, I'm limited by the amount of eggs that I have. And my theoretical yield is limited by that. And so again, my theoretical yield would be 16 pancakes. So let's kind of go back also with that and look at the water example. So we took hydrogen and oxygen to make water. What I want to highlight here is that, again, what this balanced equation means is that this reaction requires 2 moles of hydrogen for every 1 mole of oxygen to make 2 moles of water. Now, if I only have half a mole of oxygen, I can't make 2 moles of water. Or let's say I have the 1 mole of oxygen, but I only have 1 mole of hydrogen. I can't make that whole 2 moles of water that I want to. So let's just kind of look at an example here. So let's say if I have 2 moles of hydrogen and 1.5 moles of oxygen, how much water could I make? So our first step in this problem to answer it is to find our theoretical yield. actually, sorry, let me back up to find the limiting reagent because that determines our theoretical yield. So the easiest way to do this is let's do this calculation for both hydrogen and oxygen. So 2 moles, if I have 2 moles of hydrogen and the balanced equation says 2 moles of hydrogen makes 2 moles of water, that means theoretically I could make 2 moles of water. Now I'm going to do this with oxygen and compare the results. 1.5 moles of oxygen, how much water would that make? Well, the balanced equation says 1 mole of O2 would make 2 moles of water. And so if I had 1.5 moles of oxygen, I should be able to make 3 moles of water. Now, by comparing those two results, I can determine what my limiting reagent is. Since the hydrogen produces fewer moles of water, hydrogen is our limiting reagent. And we would say then that 2 moles of water is our theoretical yield. Because what would happen is we do this reaction. We would run out of hydrogen before all of the oxygen got consumed. So at the end of the day, if we were to this reaction up with 2 moles of hydrogen and 1.5 moles of oxygen, all the hydrogen would get used up. We'd make 2 moles of water, and we just would have a bunch of leftover oxygen. So that's where we're going to be going with this series of lectures. We're going to do a few examples incorporating different types of mass relationships or ways that we can report the amounts of materials in a chemical reaction.